Question number 23. Prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. So here what we are given is that we have a cone, and that cone is inscribed in a sphere. Inscribed means inside a sphere. So we are having a cone and a sphere, and a cone should be inside a sphere. And what we have to find maximum and minimum. Here I have underlined volume of the largest cone. Largest means maximum. So what I have to do is that I have to find the maximum volume of the cone. And we have to know what is the volume of the cone so that we can do that. You have to recall yourself from your school level. Volume of a cone is 1 by 3 pi r square h. Pi r square h. So now we have drawn this one. This is a sphere. I cannot draw a sphere, so I draw a circle. This will represent a sphere, and then a cone is inside. The radius of the sphere is how much? Radius of the sphere is given capital R. So radius of the sphere from O to D it is R, from A to O it is capital R. That is the radius of the sphere. And then O is the center of the sphere. Cone is A, B, D. Then in the answer, what I have written is that let O be the center of the sphere, A, B, D be the cone inscribed in a sphere of radius capital R. Next, let OC equal to X. From O to C, I have given the name X, so that I can know what will be the height of this cone. Height of this cone now, from D to O it is R, from O to C just now I have given the name X, and mean the height of the cone should be R plus X. So here height of the cone is R plus X, and then what will be the radius of the cone from A to C or from C to B. To find radius of the cone, I have to join from A to O. Length, this also should be the radius, I mean capital R. So I have to use the Pythagoras in this triangle AOC. Hypotenuse is R, perpendicular is X. So to find the base, that means it will be hypotenuse square minus perpendicular square. So base square is hypotenuse square minus that one minus perpendicular square. So if I want to find only the base, that means I'll have the square root. That one you can do it in the rough. So radius of the cone, you will have square root of hypotenuse square minus perpendicular square, I mean R square minus X square. This we find it from triangle AOC. Now let V be the volume of the cone, because V what we have to find maximum. V is equal to 1 by 3 pi. In the actual formula we have 1 by 3 pi r square h. But here what is the radius? The radius of the cone in this case is square root of r square minus x square. So r square, when I square this one, square and square root will get cancelled. So you will have only r square minus x square. And then in place of height, this height, what will come? R plus x. So I'll have that one, r square minus x square in place of radius square, and then height r plus x. So from here, multiply these two terms, r square multiply r plus x minus x square multiply r plus x. From here you will get that term. Next, we have got the value of v, function v. So our function is v here. So now we'll proceed with the second order derivative test. I mean differentiate 2 times. Differentiate it with respect to x. So we'll have 1 by 3 pi and then r cube is constant. So when you differentiate r cube, you'll get 0. Why it is constant? Look at the equation. In a sphere of radius r, that means radius is given r. Given, that means your radius is given. So r will be a constant because radius is given in the equation. So when you differentiate r cube, constant, that means 0. R square will come up, differentiate x with respect to x only. So you'll have r square only, dx 1. Differentiate r x square, r is constant, differentiate x square, you'll have 2x. Differentiate x cube, you'll have 3x square. Then differentiate this also again with respect to x. You'll have 1 by 3 pi r square. R is a constant, so r square also will be constant, 0. So from here you'll have minus 2r come up. Then you'll have to differentiate x 1 only. Differentiate 3x square, you'll have 6x. So now we move with the second step. For maximum, what is our function here is volume v. For maximum v, dv by dx. Here we differentiate with respect to x equal to 0. So 1 by 3 pi of that equal to 0. 1 by 3 pi cannot be 0. So this term has to be 0. So from here I have to split the middle term. Split the middle term. What is the product? 1 into 3. So 3, 1 and 3 should be the middle term. So here I have used 3, here I have used 1. 1 I didn't write it. That means minus 3 rx plus rx will give you back minus 2rx. So I have written here, I have split the middle term here. So from there you take common, and then you will have r minus 3x, r plus x equal to 0. And then again, r is a radius, cannot be 0, x also cannot be 0, r plus x together cannot be 0. So this term has to be 0, r minus 3x equal to 0. So from here, x equal to r by 3. Next, with the third step, at x equal to r by 3, find the second order at x equal to r by 3. We have to replace x by r by 3 in the second derivative. So cancel here, 3 into 2 will give you 6. That means you'll have minus 2r, it will give you minus 4r. So together will give you minus 4 by 3 pi r. And then when you check this one, you have minus, it will be less than 0. When we have less than 0, that means we have a maximum. Therefore, v has a maximum at x equal to r by 3. And the maximum volume of the cone is v. This is the second part of the equation. See in the equation what we have to prove after finding maximum. Prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. I mean, after finding maximum volume, what you have to prove that volume should be what? That volume is 8 by 27 of the volume of the sphere. So now V is equal to 1 by 3 pi. In place of x, what I have to put? R by 3. So in the beginning we have the function V. All x should be replaced by R by 3. Here we have x squared and we have R squared by 9. And then here we have x only, R by 3. This is the beginning volume of the cone. So we put x R by 3, x as R by 3. Here we have it square, so we'll have R squared by 9. So what I'll have here, put the value here and here. You'll have now 1 by 3 pi. LCM is 9. You'll have 9R squared minus R squared. LCM is 3, 3R plus R. You'll have 8R squared. Here you'll have 4R by 3. But we should remember that what we have to prove is that volume should be 8 by 27 times volume of the sphere. That is what we have to prove. So I'll try to take out 8 by 27. 8, I take it out. 3 into 9 will give you 27. That I have to take it out. Then what is remaining? You write it here. What is remaining? Number remaining is 4 by 3. 4 by 3. Because this number already used 8. 3 into 9, 27. So remember, number remaining is 4 by 3. And then pi is remaining. R square and R will give you R cube. So what we are going to get from that, we are going to get the answer. That means the volume is 8 by 27 times volume of the sphere. Because the volume of the sphere from your school level you have known is that 4 by 3 pi R cube. That is the volume of the sphere. So we have got the answer. We have proved that the maximum volume and also the volume should be 8 by 27 times the volume of the sphere. So up to that much will be the answer.